Hello, here is a quick video on section 3.5a, which is going to be talking about scatter plots, their association, and the lines of best fit, or we often call those trend lines. So, as we get started here, we're going to talk about some relationships that variables have. So, here's a graph of temperature after sunrise, and you can probably already guess or know that after the sun rises, the weather starts getting nicer, usually, right? Now, this is not a perfectly straight line, but as the hours increase, the temperature increases. So we can say when y increases, x increases, which means that has a positive association. It's basically like saying they have a positive relationship. Or if I were to draw a line as much as I could through those points, it would have a positive slope. Here's another example. This is the temperature after sunset. So the sun goes down below the horizon, it gets darker out, which often leads to it getting cooler outside. So again, these are not in a perfectly straight line, but we will notice that the y values or the temperature is decreasing as my x values are increasing, as the hours after sunset increase. This is said to have a negative association. And if you were to draw a line through those points as best as you could, that line would have a negative slope. And it has a negative, these variables have a negative relationship with each other. Then we have rainfall after sunset, and this graph looks a little bit different. So again, it gets cooler outside, it's darker, but you'll notice that the amount of rainfall is kind of all over the place. There's no way I could try to draw a line through here and be certain that it's going to match most of the data or follow the trend of the data. And so this is a situation where there's no relationship really. So we call it, say it has no association. So again, association is just a word that represents relationship. Okay, what is happening between these two variables? As one increases, does the other increase or does the other go down? Here's another way where you can look at association. Instead of looking at it from a graph, you could look at it from a table of values. Now, these tables of values are not necessarily going to be perfect tables of values like we've seen in the past. They're not going to have the same or constant rate of change because these are real data values. They're not going to go up or down by the exact same amount. But we can see a general trend happening here. So as we look at this first table, we are increasing on the x's. And in fact, we're increasing by 1. This one happens to have a constant pattern up there. But on the y's, we don't have a constant pattern. So the 3 stays the same, but then we increase, and then we increase, and then we increase, and then we stay the same. But overall, you can pretty much, you know, assume or estimate that as the x's are increasing, the y's are also increasing. So we would say this has a positive association. Okay, in the next table, we'll look at some trends that are happening. Okay, we increase for the X, it stays the same. We increase, we increase, we increase, and we stay the same. So again, the X's are increasing. Most tables will be written as the X values increase, but not all. So let's notice what's happening with the Y's. We stay the same, we decrease, we decrease, we decrease, we stay the same, and we decrease. So again, the trend seems to be following the pattern of the Y values going down. So we would say this has a negative association. It is not a perfectly straight line. It doesn't have a constant rate of change, but in general, as we go to the right, the points are going to be going down. Now, these lines I've been talking about do have a name. They're called trend lines. Sometimes you might have heard them referred to as lines of best fit, but it's just a line that models how the data is going in the general direction, right? When you draw a trend line, you're going to try to draw it in the middle of the points. It does not necessarily have to cross through the data points, just kind of be in the middle of them. Now, we want to make sure we understand what lines of best fit or trend line means trend lines mean in the context of the problem. So here's an example where we're looking at the relationship between age and the number of emails per day. The equation for the trend line is given to us right up here. Okay, so we don't have to figure it out, we just know what it is. We want to describe the y-intercept, what the y-intercept and the slope mean in the context of the problem. So I know the y-intercept is 35 because I can look right up there in the equation and see it. You could look at the graph, but sometimes it's a little harder to tell when we're dealing with different scales. So I know it's 35, but what does that mean? Well, all y-intercepts have an x value of 0, and so I can use that to my benefit. X in this problem, our x-axis is talking about age, and our y-axis is talking about emails per day. So I'm just going to say emails. So if I put those two things together, I could say when 0 years old, you have 35 emails. Now, does that make sense? Not necessarily. Sometimes our trend lines are going to have values, especially y-intercepts, that aren't necessarily going to make sense because they're going to be outside of kind of reasonable data, right? A 0 year old isn't going to have emails. But that would be what that means in the context of this problem. If we look at our slope, again, we know our slope is -1/2. As a reminder, you can put that negative on either the top or the bottom, but you can't put it on both. So I'm going to do -1/2. And slope is always rise over our run. So let's think about what that means in the context of this problem. Our y is our emails and our x is our age. Now, this is a rate. So this is emails for age or our years of getting older. So we can say that as we, or every, let's say every 2 years, okay, so as I grow older by 2 years, the emails go down by 1. Okay, that's one way you can say it. Now, that's not the only way you could write it. You could say, my emails decrease by 1 for every 2 years, or something along those lines. But that's kind of the general idea, is looking at what is the slope, thinking what those variables mean, and then putting it in some sort of a context of the problem. I hope that helps. Have a great day.